Hi, I'm Mohit Agarwal. I'm trying to explain deep learning with TensorFlow. I'm a PhD student of Bennett University. I have taken the slides and materials from this link. My courtesy to Brian Pug for his material. I will start with simple deep learning example and then explain TensorFlow related to it. Our goal is what is deep learning and what is artificial neural network. A basic artificial neural network and implement a basic network for classifying handwritten digits. What is deep learning? Deep learning is a branch of machine learning, multiple levels of representation and abstraction. It is one step closer to true artificial intelligence. It typically refers to artificial neural networks. Externally can be thought of as a black box with many inputs and outputs with rules to learn from its training. Training comes from known input and output datasets which are labeled. For example, if we want to classify an image whether it is containing a dog or a cat, then we can do deep learning and it can tell that whether it is a cat or a dog. For a dog, it is giving, if it is giving 99% accuracy chances, then we can say that the image is containing a dog. Similarly, if the image is containing a cat and we have trained the network using deep learning and for 99% it is saying that it is a cat, then we can say that that image is containing a cat. Similarly, if we are having a distorted image of a dog and it is saying 55% chances it is having a dog, and we can say that the image is not very clear which is having a dog. In a similar way, the image which is not having a cat very clearly, it will tell that it is having 55% chances that it is a cat. So it is a continuous graph from 0 to 1, and we can know to what percent we can predict that whether the image is having a required object. For example, if image is having two rats, then it will be bit similar to cats, and thus it may say that for 75% chances it is having a cat and 25% chances that it is having a dog. Now, what is a neuron? It is the inspiration for the artificial neural network. It is the part of a human brain in which it is having this kind of structure with dendrites, nucleus, cell body, and axon endings. So it will be passing the information from left side to the right side, which will finally reach the brain and be interpreted as a uh, classifier, which will tell that what object it has recognized or what information it has recognized. Similarly, if we compare it with the artificial neural network, then it will be of this form with inputs x1, x2, x3 till xn, each having a weight w1 till wn, which are like dendrites. And if we sum this value using sigma xi wi, then it will be the sum, which is the nucleus. And then if we pass it through an activation function, which can be a ReLU or sigmoid. ReLU is a real rectified linear unit. Then it will convert it to some scalar value, and this will be the output of this neural network, which is the axon ending. So this is a comparison of a uh, uh, neuron with the artificial neural network. Now, if we combine these layers, then we will get a deep neural network in which the output of first input, the output of first layer will be the input to the first hidden layer, and output of first hidden layer will be the input of second hidden layer. Similarly, it will go on till we get the final output. This is a deep neural network. Now, back propagation. How does it works in neural networks? The neural networks is having a weight, which is the useful information, and how we can learn it. We will learn it using the TensorFlow, which is having the gradient descent property, and it maps the final output to the required output and keep on updating the weights in the network. What is training in a nutshell? We will pass some example input and compare the network output with what the output should be. Backpropagation backs moves backward in the network and updates the weights values. Whenever the network gets that input, the output should be closer to the goal output. Now for training the dog and a cat classifier, we will train it using a deep learning with the trained images and seeing that this image is having a dog and this is having a cat. And after that, once it is trained, it will predict the output for a new image with some percent of accuracy. Similarly, this image is showing that it is telling that whether the image is having a cat with 73% accuracy. And these images are showing that how much percent of accuracy we are obtaining on different type of images. Now we will train the dog and cat classifier for tens and thousands of images, and that number of times. Coming to TensorFlow, it is a Google publicly available deep learning library. It is becoming more and more popular in industry. The power of GPUs, which is used in TensorFlow for parallel computing. How do we install TensorFlow? Download and install Anaconda. Download and install TensorFlow on Anaconda prompt using pip install TensorFlow. Now, how to use the TensorFlow? We will use using import TensorFlow as TF, and TensorFlow functions can be called using TF prefix, example tf.session. Now we will take the example of MNIST dataset, which is the images of handwritten digits. We will write from TensorFlow examples tutorials import input data. This downloads and loads the MNSIT digits dataset. Note 784 is equal to 28 by 28, so we will resize the images to 28 by 28 pixel. We will import matplotlib.pyplot.splt and open the images and reshape it to 28 by 28 using image reader. Then softmax and one-hot encoding. We want the network to output a percent certainty it believes some images belongs to some label. Softmax remaps the output layer to percentages. For example, softmax Vj is equal to EVJ over sigma EVI over all I. For example, 1, 1, 6 will be mapped to 0.0066, 0.0066, 0.9867. Now, if we are having digits from 0 to 9, then 3 will be mapped to the vector of this form 0, 0, 0, 1 and then 6 zeros. How do we train, validate and test? Typically training data is 80 to 90%, validation is 5 to 10% and test data is 7 to 15% of the whole data. We will check the performance during training with validation data and see actual network performance with test dataset. We will construct a feed-forward fully connected neural network that is one layer deep, in which we are having inputs which is mapping to the 784 pixels of a 16 by 16 image, and its output is a vector which is of having length 10, which is the digits from 0 to 9. Each pixel will have associated weights, one for each layer. There are 784 pixels in each image, therefore our weight matrix will have dimensions 784 by 10 because there are 784 inputs and 10 outputs. Now artificial neural network simplified. Some scalar values on the left side input, which is x1 to x784, weights w1 to w784, they are sum, then some activation function and then some output percentage, example 6. What are input variables? Input variables, we will create a placeholder x equal to tf.placeholder with the type float and of the size none comma by 784. None means the first dimension can have any length and 784 is the size of one image. This is again the same in which where we have simplified the image. What is a TF variable? Weight. Weight is a variable because it will be updated in each iteration. Initially the elements are set to 0. Unlike placeholder, variable contains determined values. Now what is a bias? Bias is a constant which we add to the neural network. It is shown in the figure, and it is a constant value which will be updated by the backpropagation. B is equal to TF dot variable. This will have the dimension 10 because there are 10 outputs. So we will add B to each vector of the output. All elements of B are set to 0, unlike placeholder variable contains determined values. So this is the final neural network which we are having. Now what are network output variables? For example, y is equal to tf.nn.softmax, tf.matml x, w plus b. This performs a matrix multiplication between input variable x and weight w and adds the bias b. Then softmax performs the softmax operation discussed earlier, and y will have dimension none by 10. Again the same description in which we are having the TensorFlow working with the same diagram. The ground truth output variables. For example, if we are having y truth equal to tf dot placeholder, tf dot float 32, none comma 10. This creates a placeholder variable y truth. It's just like a variable like in maths. Placeholder for ground truth, one hot lot label outputs. It is of type TensorFlow float 32. It has shape none by 10. Loss variable. The loss variable is the reduce mean minus tf dot reduce y into tf dot log y. So tf dot log y turns values close to be 1 to be close to 0, and the values close to 0 to be close to minus infinity. Y truth into tf dot log y only keeps the value of the actual class, and tf dot reduce sum along the class dimension, and reduce mean averages the vector into a scalar. Now loss variable example. For example, if you want to predict a cat and a dog, and it is having the accuracy 0.25 or for cat, and for dog 0.75, then the loss function will have a value because 0.4363, which is of the previous equation, and the ground truth will become 0 for values less than 0.5 and 1 for values greater than 0.5. Now implement the training algorithm. If we do the train step as tf.train gradient descent optimizer LR, learning rate dot minimize loss. Learning rate is how much you proportionally change weights per training example, and minimize the loss function. Now begin the TensorFlow session. Up to this point, we have just been laying down the blueprint for TensorFlow to follow, but it hasn't built anything yet. If we do init tf.global variables initializer and ses dot equal to tf.session, and then we can do ses.run init. Initialize the variables and create a run a TensorFlow session. Now we run through the training data set. For I in range 1000, we will do x batches comma y batches equal to train next batch, and then ses.run train step comma feed dictionary x from x batches and y truth from y batches. We repeat it 1000 times, get a small random 100 subset of a training data set, train on that small subset, and then we decide that it may have trained the network with the weights we are needing. How well it performs? If we get the prediction using tf.equal tf.argmax y comma 1 comma tf.argmax y truth comma 1, then it will tell that it is correctly predicted or not, and the accuracy will be tf.reduce mean tf.cast correct prediction into float 32, and then resultant accuracy will be ses.run accuracy comma feed dictionary x from MNSIT test images and y truth also MNSIT test labels. So it will tell the train